Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the basic rules of exponents and illustrating them through some fundamental examples that will get your foot in the door as far as understanding. So quick recap of the rules you should have already seen in the concept video. This is the multiplication of two like bases. You add the exponents. If they're divided, you subtract the exponents. If you get a negative answer for the subtraction, you flip it to the bottom. Not any numerical coefficients, just that variable that got the negative answer. If you got one power raised to another power, you multiply the powers. If you got multiple things multiplied raised to the same power, you multiply each one of those powers, including if there was a numerical coefficient. Don't forget those numerical coefficients have an exponent of 1 understood to be there. Okay? If you've got the same scenario and they're divided, you still just multiply each exponent. Anything to the 0 power is 1. Negative exponent flops down to the bottom. And if there's a numerical coefficient like this 3 here, it would stay up in place of that 1. Here, let's just rewrite that. That looks sloppy. So that would be a 3 on top. And if the negative exponent is the denominator, you flip it, moves it to the numerator. So here are some basic examples. Let's check these out. Here we got multiplication. So take the coefficients. 2 times 4 is 8. And then you have x times x. So we add the exponents, two like bases being multiplied. And then we have an understood 1 there if there's nothing there. So you add the 3 plus 1 in order to get an 8x to the 5th, y to the 4th. Okay, hopefully that was pretty clear. Let's look at this example here. If we have a negative exponent, don't forget the 8. The numerical coefficient has a 1 exponent, so it would be 8 to the negative 1, x to the negative 3, y to the positive 3. Then we would take the negative exponents and flip them to the denominator to get our final answer with positive exponents once they've moved down. All right, so we took, the rule was one exponent raised to another exponent, you multiply each one of those exponents. And negative 1 times positive 1 give you negative 1. Negative 1 times 3 give you negative 3. Two like numbers being multiplied, you get a positive 3. Okay? All right, let's look at the next example, a little bit more complex here. Numerically, we know that 5 goes into both of these numbers, so that's what 5 times 5, whereas the denominator is 5 times 3. Cancel the 5s, and then you'll be left with 5/3 as a coefficient. X to the 2 minus 4, y to the 1 understood there, to minus 5, and then that z to the minus 1. That's going to give us a 5/3 z, or x to the negative 2, y to the negative 4, z to the negative 1. Since all of these exponents have negative signs attached to them, they all need to move the denominator. The 5 is going to stay in the numerator, however, because it doesn't have a negative exponent. So it would be 5x squared. Notice the sign is now positive when it flips down to the bottom. And there's your final answer there. Okay, so I did some simplifying first, numerically, then used my exponent rules. Now, if you feel comfortable saying, hey, there's an x squared and next to the 4th there, I'm left with x squared on the bottom, by all means do that if you can see that. I know some of you have been working with exponents for a while. Some of you haven't had a math class in many years, so if you got to go back to square one, no worries. Just take it one step at a time. We got 4 to the 2nd power. This is 2 times the 1 that was there. And then 3 times 2, and then again 3 times 2. So this one wasn't as bad as the last one. We got 4 squared, x to the 6th, y to the 6th. So that's 16 x to the 6th, y to the 6th. That's a Now, those of you that are perceptive will see that this is a 0. And right away should say the answer to this is 1. Because anything to the 0 power is 1, with a few exceptions in calculus, but we're not dealing with that now. So some of you might have, simplified this, made that 9 times 9. Actually, 81 is 27 times 3. I just figured that out. So let's try that again. That looks very sloppy. So the 27s could cancel. And then we would have x to the negative 2, y to the 1, y to the 1 over x squared. But again, all that's raised to the 0. So eventually you're going to have to deal with that 0 exponent, which would give you 1. So actually it would give you y to the 0 over x to the 0, which is 1. But just keep an eye out. If it's raised to the 0, automatically make it a 1. That's just the easiest way to deal with that, okay? Here we have a multiplication problem. So remember, you can cancel diagonally. I'm going to do this one problem without doing the a minus b rule and just kind of show you how it would work if you were canceling. For instance, there's x squared there, and this is x to the 5th. So if I take 2 of the x's from the 5, I'm left with x cubed. And whoa, I see an x to the 6th up there. So let's go ahead and mess with that, get that out of the way. And since there's 3 here and 6 is larger, I'd be left with x cubed on the top. And then let's see, we have any other variables that can cancel? No, the y's are on the same level, the z's are on the same level. We can't cancel on the same level. It has to be either up or down or diagonal. And speaking of diagonal, I know that 4 goes into 16 4 times. I know 9 goes into 27 3 times. So if I were to multiply, I would have y times y, and remember both of those have a 1 understood there. So it'd be y to the 1 plus 1, because you're multiplying the like bases. And then there's an x cubed, right? Remember this one? So we would have x cubed. And then over 3 times 4, and then no x's left, but we do have a z to the 1st times a z squared, and since they're multiplied, you added their exponents. So you get a y squared x cubed over 12 z cubed. And that should be your final answer for that one. Okay? So you can see there, if you get familiar with them, you can just start canceling through them. You don't have to be as formal showing the steps. But if you're taking a quiz or a test, it doesn't hurt if it's on exponents to show these steps, because you might have made a silly mistake. You might have been tired because you crammed and studied them properly, and you thought, 3 plus this 3 plus 2 ended up being a 6 magically. Well, if you actually wrote out the 2 plus 3 step, the professor knows that you know the rule. You just were too tired to do your basic math properly. And usually 9 times out of 10, they'll give you the benefit of the doubt. So you should have your foot in the door with exponents, enough to just do a few problems, get your mind, thinking about how to work these, refreshing your memory if that's the case. And practice, practice, practice is the main key to most subjects. Watch the intermediate video and the advanced video as well for more examples. I hope I've cleared up any confusion that you might have. Thank you, and have a nice day.